Hello, I'm Dennis Preshak, President and CEO of the Plastek Group, and I want to thank you for attending today's webinar at the Plastek Academy. Today we're very pleased to have one of our most valuable and longtime suppliers, Norwalt, share their story and expertise in automation with you. Plastek and Norwalt have worked together for more than 30 years on complex, high-speed part assembly and other automation, and I cannot say enough about the technology, value, and very strong customer service they've provided us through the years. What you'll see today are numerous examples of how Norwalt stays ahead of the game and provides solutions to even the most difficult challenges. Regardless of industry, speed, or part complexity, if your products need handling or secondary operations of any kind, Norwalt has the right solution for you. You can take that to the bank. Plastek has and will continue to do so. With that, I'd like to thank you again for watching. I hope you enjoyed today's presentation and happy learning.
Okay, hopefully everybody can hear me okay. Thank you, Nicole and Dennis, and thank you to Plastek for allowing Norwalt to be part of your webinar series. We've been a proud partner with Plastek, as Dennis said, since the 80s, partnering on many projects over the years. So thank you again. Thank you all for attending today. Our objective today is to give you a high-level view of Norwalt and some of its capabilities and some advice hopefully for you on planning some of your automation projects. So let's get right into it. I would like to introduce myself. My name is Keith Harman. I've been in automation for 40 years this year. I wear several hats within the Norwalt organization. I'm a key account manager for our customer base and also a vision systems manager and assist Mike Zeitel, our CEO, on customer initiatives. Mike is going to be the key speaker today with me. I'll be butting in now and again. So with that said, I'd like to introduce Mike, our CEO, Mike Zeitel. Over to you.
Thanks, Keith. So a little bit about Norwalt. Let's see if this mouse goes forward. Just bear with us as this, I think there's a little delay here. There we go. Now it's starting. Okay. I want to thank Dennis again. I know Dennis for quite a long time. I've been with Norwalt 34 years. And I initially met Joe, which is, I remember way back, he was one of the most remarkable people I've ever met in the industry. He's one of those guys you could shake a hand with and you could take that to the bank, as Dennis said, as a purchase order. And I continue to do that with Dennis and Doug and the boys there as I've grown through the business with them. Norwalt's family-owned business. We've been around since '71. At this point, we have 65 employees. We don't do any machining in-house, but, whoop, wrong way. Let's see, this way. Hang on. We pride ourselves on our customer service. There we go. Now it's starting to work. And our quality of our machines. Over the years, we've really changed our philosophy. Instead of just trying to get the big sale, we go after getting the best machine to the customer that we can. And any troubles, there's never a question on who's paying or what needs to be done and whose fault. We always send a technician out, no matter what. And the big thing is keeping customers up and running. We had to expand quite a bit over the years. We're really shipping our machines all over the world now. Some of our end users will select our machines to go to North America, South America, and Eastern Europe and Asia these days. So we had to do something about it. We opened up a sales and service center out of Taiwan where we have engineers based just to cover the Asian market. And that's been invaluable for us, just for us to be able to give quick response time. One of our things is always being able to do that and get to a customer within a few hours response. Our customer base is very broad. We do a lot of work with injection molders such as Plastek. Over the years, with all the buyouts, that's consolidated, I'll say. So now there's only the bigger molders such as Plastek and others that we work with. We do quite a bit of direct work with end users. Probably it's a 50-50 split in terms of injection molders and end users. And in terms of what our expertise with them, it's all over the map, right? We'll do assembly machines, division, and other things, and I'm going to go through all that briefly. I don't want to make this a Norwalt event, but I'm going to go through some of that and then go over some of the things that should be taken into consideration when looking at automation and the various types of automation. One of the big advancements that has helped us is the advent of the 3D printers. This isn't new to anyone here, but it has really done a huge turnaround on quotes. Number one, we're able to print out the parts that customers want us to assemble overnight and play with them, because you still want to have something in your hands to be able to look and touch and feel and decide what's the best way to automate it. And it also, we've even had some, because we have some onyx material we're using with carbon fiber, that we're actually making tooling, end of arm tooling on robots with. And that has done tremendous lead time improvements for a lot of things. Because now engineers, it's kind of funny, because in the old days, we'd have to get a piece of tooling from the machine shop. It would take a week. And of course, you know, we'd all know, hey, it didn't work. Now they'll print it overnight, and then we'll go to look at it, and it's already could be in the garbage because it didn't work, and they have a new one printed that works. And it really helps that cycle time tremendously. Our industries that we work with are medical device, life sciences, personal care, food, beverage, household, and communication. And they're pretty well split. Medical device is probably 50% or more of our business. And then the rest is personal care and food and beverage, probably in the 30 to 40%. And then communications, that's a lower amount, and some household items. But the big thing is personal care, food, and medical device. COVID did change that a lot, and has almost forced a lot of the machine builders into that, just to help out on some of this that was needed last year. The bulk of our work is custom assembly machines. We look at each project as a custom solution. Over the years, I've seen a lot of machine builders try to go and fit an automation package in, hey, this is our standard platform, and let's use this, and we expand it, which is good for cost savings. It shortchanges the end user a bit, I believe. A lot of machine builders have struggled with OEE because of that. And we go and design from scratch. Well, we'll use other proven technologies, but what we're found is to use the right solution, whether it's continuous motion indexing or a combination. And I'll go into some of those different types of machinery later. So there's a lot of things that we'll put into the machine, such as decorating, leak testing or pressure decay testing, lining, which is punching foils into caps, labeling. We'll integrate labeling systems, vision inspection, which Keith is going to go into quite a bit, filling, induction welding, conduction welding, ultrasonic welding, serialization for tracking product that goes out in the market for FDA, and machine health monitoring. Just one item of note in the picture here, you see we have a new patent that we're in the process of fine tuning for direct object printing of oval containers. Right now, that's something that no one can do fast. We have a new way of doing it, and it still has a little bit of development, but initial tests are in the 250 to 300 parts a minute, where everything on the market, I think, is about the 40 to 50 a minute. So that's some exciting things with sustainability and not having to put labels on things. I think would be a great thing for the environment and also for e-commerce. Everything is going toward the print on demand type applications, and this could be something that is used around the world in small cells or large at the end of the line of filling lines, where you can change things and go, like if it's a Super Bowl, you could do the Chiefs and the Patriots and literally change every other product that comes off the line. We do quite a bit of case packers for specialty items. So there's a lot of drop type packers that Hartness and people like that build that are very good. But the oddball stuff, taking oval containers, taking orange juice caps and staggering them in patterns, or cosmetics, those are the type of things we specialize in. We'll take them and do them from the mold. We'll do them with feed bowls as standalones, and we'll do them at the end of line. This picture here, as you could see, all these tools here up in the, that are holding the containers, all 3D printed tools. You can run the air. It's fantastic what you can do now and design with the 3D printers. Tray loading is something we had to get into recently, and this is really primarily because of COVID. Last year, we got involved. The picture here is for stoppers that went in the vaccine vials. We had to get involved with PCR tube capping, all kinds of things like that. And everything before this year was always done quite slow. It was amazing how slow a lot of this stuff was done. We patented some concepts we had to come up with quickly, and now have methods of putting tray loading and also doing PCR capping and loading all at high speeds. I'm going to turn it over to Keith, because he's the guy that really has pushed us into a lot of new areas with vision and inspections, and let him discuss some of the new items on the market for that.
Yeah, thanks, Mike. So apart from all the special stuff, Norwalt machine vision, like Mike said, has had to grow generically as well, with just all the normal vision that everyday objects need, as you all know. There's the 1D, 2D, 3D PC-based vision that we use for barcode reading, OCR, OCV, part measurement, flash and short shot detection, etc. All of that stuff is your day-to-day vision that we do pretty much put on nearly all of our equipment now. There's very few machines that go out without any type of vision on. But above and beyond that, we've also got the normal Norwalt Pharma Vision, which incorporates and works alongside serialization, track and trace, audit trail for all of our pharma and non-pharma, but FDA style products. These are all standard applications, again, which we build into our standard equipment, or can retrofit to ours and other people's equipment. But we've had a recent growth in the vision side, an interesting growth, that instead of just doing what we call the process vision, which is, as you can see in pictures here, we're looking at parts in the machine already and checking for quality post-assembly or post-fill or post-packaged product. We're getting a lot of growth now from our customers that want pre-process vision. And what that does is that we're doing some great analysis work and ML work, machine learning work with AI on systems prior to going into whatever machine it is, whether it's a normal machine or other machines. But this growing trend incorporates ML using also a Norwalt closed loop technology that we've worked on very hard over this year. And what it does is that it will typically reduce operator interaction, and in some cases even eliminate operator interaction. And let me give you an example so you can maybe understand what I'm talking about a little bit. Earlier this year, we deployed a machine learning vision system, an AI system, on the in-feed of an existing Norwalt plastic container line. That gets 3 parts assembled and then ultimately filled, capped, labeled, boxed. We set up the AI system on the front end of this system on the in-feed before all the parts get assembled, so that it learned typical quality levels of the product. So the AI learned itself and could differentiate as those tolerances of parts, and we all know it happens, right? As the part tolerances start to go in and out or deform, we would allow those quality levels to be fed back into the final manufacturing process. And when they deviate from the baseline, what we do is we will alert the operator, or we can reject because they're too extreme. But if they're within the tolerance bounds that we've set with the AI system, we can dynamically adjust the machinery to allow for those slight defects in the product. And we will automatically adjust label positions, cap positions, just to overcome some of the deformation in the product. Although that product is slightly deformed, it's not out of tolerance. And when we did this, it was amazing, the return we got. This one system applied to a large plastics house we put it in, saved rechecks and downtime in the order of 5 to 8%, equating, they told us, equating to over $1 million per annum for one production line. So that side of the vision world is becoming really important, the AI and the machine learning side, where we're actually taking data models on the in-feed of systems and managing the machine around it. So quite an intriguing concept. As well as that, we have, I run the initiative on predictive maintenance, where we use IoT, deterministic stuff for learning early or premature failures for investigation. We've also just recently done a really nice system, which is growing in popularity. We're getting a lot of requests for this, where we're deploying machine vision to replace conventional CMM. Now, CMM, this is mainly post-mold, so not for everybody, but it's another example of how we're pushing the envelope and designing and always looking for new ways for customers. And that is that the CMM, if anybody knows how a CMM operates, you get a 64 cavity mold, takes 30 minutes for all of those molds to be passed. Well, we've gone into a situation where we can now reduce that R&R gauging from 30 minutes down to 90 seconds using our, as you want to call it, vision CMM. So pretty good stuff, you know, so we can cover all of your expectations. Another good thing that might interest the audience is we have a full lab here at Norwalt, which is new in the last 4 years. And what it, you know, the importance of the vision and the AI and everything everybody knows, we want to do the design and analysis upfront properly for customers. So they will send parts into us for feasibility studies so that they can make sure that everything is going to be 100% accurate prior to deployment. And another thing that Mike just recently did for the company, which is great, is we've built a mock factory area where we can simulate and do vision testing in a replicated production environment. So we're running the product at speed with rejects, exactly replicated to the customer's situation. So when they come on site to us, customers come to us on site and they do an FAT, they're seeing their machine there running pretty much. So I know that, and that's mainly for add-ons or to existing systems or to new systems, as opposed to, you know, if we're building a machine with vision, that's different. But if we're adding a system to a customer, we'll replicate fully that system in-house. So a lot of good stuff going on there. And Mike, back over to you.
Okay, thanks, Keith. There we go. Some other items we do a lot of filling with different styles of pumps. We use peristaltic, positive displacement, all different styles of them, and different levels. A lot's in the very small dispense for the medical industry, but we will do some larger ones. We're not trying to do the big fillers like the beverage and all that, but more the specialty type fills. And a lot's done for high speed now, where which is our expertise. There we go. All right, feed systems. Probably everyone on this call uses feed systems, and a lot of times they're a pain in the neck because you're taking parts from random and trying to sort them all in one direction. And Plastek actually worked with us to help develop this patent. I got to thank them for this. We were working down in their Hamlet plant, and they said, what can we do to help improve OEEs? And we came up with a method to automatically unjam feed systems, and on centrifugal bowls, we actually take them and make them go in reverse. And this just tremendously increased OEEs on the overall lines. And another big plus was operators aren't going in there to adjust things, because yeah, operators, everyone wants the machine to work well. It could be some bad parts they get in there. They go to try to make the feed bowl work for the bad parts and adjust something that shouldn't be adjusted. But if the feed bowl unjams itself and keeps going and they don't have to go in there, they're not going to adjust anything. So this really has done tremendous improvements for everyone. All right, some general guidelines I just want to go through is when to automate, what needed to automate from our standpoint, and the types of automation with some pros and cons. So this year has been crazy where customers are calling us in, not for your typical automation, but no one can find operators now. So we're walking through plants with some of our preferred customers and just taking a tour and looking at where they have manual labor and what can be done to reduce it with various types of automation. In the old days, say they use $40,000 or $50,000 a year for an operator, but that just was for the cost. Today, people are changing that number and looking at the lost opportunity figure. So they're adding another factor in, because if they don't have the cost of the operator, but the lost production because no one's at work anymore. So we're doing quite a bit of this type of reviews with customers to help them. Oop, went a little quick there. So, and this is something everyone should do, is if you have a good partner automation house, is bring them in, have them walk through the project, your floor, look to see what might be automated. Be sure they have some, you have some budgetary numbers that you think you could spend, to be sure that it's not a, if you say it's $10,000, you're not going to get a lot for that. So you need to at least have some realistic numbers in mind that you're going to spend to reduce labor. And that is something that everyone is starting to do now. The other type of automation we get involved with is the typical injection molders. We'll have all 10 of them call us at the same time within hours on a big project from an end user. And in-house developed projects, which could be at the end user or at the injection molders. Now, one thing that really helps a lot for everyone is get people like us or another automation house involved with your part designs. So a lot of part designers really don't like me that much because I go and critique them and tell them, look, change this, without changing their outside shape, but at least with making it so you can put it together, because the industrial designers don't really have that knack or skill set to do that. They make a lot of pretty pictures and you're like, hold it, this won't stay together, this won't do this. So work with an automation house, you'll save a ton of money, and we all do that for free, whether it's us or our competitors. There's no charge for that, and it'll save you oodles of time and improve your OEEs in the end. Okay. All right. Couple things we will need in the automation process is samples. A lot of times we don't have samples today. Get a step file so we can send them to the printer. And one thing we want to always know is what inspections needed, and if it's a budgetary quote. Like a budgetary quote we can turn around quickly, but firm quotes, they take quite a bit of work. So we can get a budgetary quote within, say, 15, 20% very rapidly, a couple of days, but firms will take longer unless it's a crisis like doing COVID machines like we did last year, where everything had to be done in hours. Speed's a big one. So for speeds, it's crazy. People will just call us and say, hey, we need 5 million of these or 500 million. And I'm like, well, what are you running? You know, how many shifts a day, all that. A lot of times we don't get this information. And one thing you should always factor in is a plan efficiency. So we like about a 15% deduction is what we use for your plant, for downtime, for maintenance. I'm going to say not machine efficiency, just for operators, sickness, or whatever it is, but no plant's running at 100%. Another item that gets missed in the calculation of the speed is colors changes. Hang on. So a typical color change, you got to figure is 2 hours to get a line clearance, get the new colors in. You know, some are faster, some are slower, but we like to use that as a factor. So if you are running 330 days a year and you have 330 colors, you're already down to 22 hours of runtime just for that. And these days, end users are, they're changing over constantly because they're going almost really just in time on the colors, not whipping a lot of stuff at the molders. So this is a big thing for just be on the lookout when you go and quote an automation speed that you have it all covered. Documents that are really good for us to get, please send us, make sure we get specs, like what is your PLC, HMI, OEE requirements, and an FAT document, what you're going to expect at the FAT. And that should be at least 6 to 8 weeks before the FAT. A lot of times we'll get something the night before and you're like, huh, this doesn't make sense. And then everyone's scrambling, the customer's trying to scramble to redo their FAT document. So these are all things that we really would like to have well in advance. FDA projects, I'm not going to go into what's needed because if all of you are on the FDA, are doing FDA type work in the medical field, you know this, but the URS is pretty standard. What's provided by the end user? The functional design spec, typically that's written by someone like us, an automation house. We or another automation house quote these documents as an option. Same as going with the installation qualification, the OQ or operational qualification. Sometimes the end users do it, sometimes we do it. And then the PQ or performance qualification is written by the end user. So And this is typically quoted as an option because half our customers will do it in-house and others like us to do it. And then sometimes it's a mix where we do it jointly. Okay, types of automation. So just to go through, I'll briefly run through these: proof of concept, semi-automatic, fully automatic. Proof of concept is one that will is really done in-house at the automation house just to prove out, can this be put together. It's usually a very minimal cost to get going. We will send some of these stations out if needed be to the end user, but once it goes out of our facility, we have to put guarding, safety controls if there's any powered components on it. Semi-automatic, this is the next step in getting product to the market. So a lot of times you might have to start a product with 1 million for the year, say, volume that has to go out. So we'll start things with semi-automatic, where in this case, an operator's loading, say, 4 products in here, and they're hitting, putting their hand over this button, and it puts them together. It gets things going while the full automatic is getting built. Now, in fully automatic, this is where you just really have the operators filling the bins, doing an occasional correction on a stop, and doing QC. I mean, and we do machines from 10 to 1600 a minute. And that goes into 3 different styles. I'll break it down to robotic, intermittent motion, and continuous motion. Now, robotic is, everyone sees that, it's the cool stuff. Everyone looks at it on TV. It's flexible, which is great. You can repurpose it. So if the project dies, you take the robot, use it for another project down the road. And they're getting so easy to program. Anyone can really take a robot and program it. It's almost like an air cylinder with multiple axes. That's how simple it's getting. The cons that I see for a robotic is it's a little slow for high. When I talk high speed, I'm talking fast, like 400 or 500 a minute. What strictly robotic companies miss the boat on is the part handling. So a lot of them want to go move the robot head as fast as they can, but the projects that I've seen fail are always the ones with the product handling. You got to get the product to the robot properly, and the cost for a robotic system is probably a little more than a typical indexing system for the flexibility. This just shows a typical, let's see if it plays here, typical robotic. If you see here, it's a little choppy, but the key is not the robot motion. That is simple, and using a robot, it's getting the product there. In this case, we were doing everything with moving it at a constant speed to keep the in-feed of the product, and this was rubber here. If you stopped and start the rubber, it's going to have more of a tendency to jam. Let's see if this goes to the next. Whoop. What happened there? Uh-oh, something just crapped out on the slide here. Whoop, there we go. Now we're back. Let me go to the next. There we go. All right, intermittent motion or indexing. The pros of this are you can do a lot of complicated things. You can do foil, heat sealing, filling, ultrasonic welding, leak testing, some decorating, and it's modular. You can expand it to more stations. A lot of the new indexing type systems out there with the magnet tracks can be added to later on, which is great. Some of the cons, it's expensive if you're going to high volume. If you're doing multiple up for these fast speeds, it gets more difficult to troubleshoot, because instead of like in this picture, this would have like 4 sensors in here, 4 valves or 4 servo motors. It just is more involved on that. I like, for a rule of thumb, figure 30 to 45 cycles a minute. So if you're doing, say, one up station, you're doing 30, 2 up 60. So that's kind of what we like to look at for indexing. We usually have a number of 100 to 120 is where you're going, okay, is it better indexing or continuous motion? That's the line where faster than 120, you're going to save a lot on continuous motion. Here's a typical indexing machine. Just show you this when I talk about indexing. You'll see it's a product, it's moved from one station to another. This is probably as simple as you can get on one, but I just wanted to show how this, you could do all kinds of things with moving foils, punching, heat staking, all different varieties of secondary operations. So it's very good for that. And with some of the new magnet tracks, you can change some of the cycles where if you have a slow cycle, you can bring two carts together, then go back to a one-up. Stop this now. Okay. Continuous motion. This is really economical for high speed. And a lot of times you could double the speed once you have a chassis. Say you're going 120 a minute. If you want to go 250 a minute, you're only going to add maybe 20 to 25% more costs a lot of times. The maintenance is almost nil on it because we have auto lube stations and the cams get lubed and he drives. The troubleshooting's easier since you'll have one sensor or a vision system doing every part that goes by instead of if it's a 4-up indexer, 4. And the changeovers can be done very easily now with push buttons. The cons, slower, if you're under 100 a minute, it's expensive, may not always be the right choice for that. And if you're looking at the end of life of something, it's going to be more complicated to convert to another system than an indexer or a robot. This is a typical continuous motion with filling and other items on here. And I think that wraps everything up now. I'm going to let Keith talk now.
Thanks, Mike. Yeah, so again, obviously you can see that we're a custom house that can work to any of your requirements, and we can do upfront design work for you and support work as far as concept, even if it is just vision or if it's the whole package. So, you know, we're happy to do that. If there's any questions, Nicole, I'm not sure if you want to try and lead with any questions there. There you go.
All right. Okay, I'm happy to join you guys. Thank you, Keith and Mike, and thank you everyone for being a part of our webinar today. I am Nicole Freeman, Corporate Marketing Manager for the Plastek Group and moderator here for the Plastek Academy. So as we move into this last session of our webinar presentation today, as Keith opened up the floor there for you guys, our audience today, you can take this moment of opportunity, follow the instructions on the screen if this is your first time joining us on this GoToWebinar platform. There is a text box where you can write in your answers or your questions, and we'll get them answered for you by Keith and Mike today. So again, thank you for Norwalt and being the experts in the next evolution in automation. And it's been a pleasure working with you guys here over the years, and a pleasure to meet you as I'm new to the scene and working with you guys. So again, audience, please take this time to write in your questions, and we'll get started as soon as we see some coming in. The contact information will also be up on the screen as we finish up here. So if you want to submit your questions first and then jot down the information, we'll give you plenty of time at the end to take those notes as well. Okay. One of our first questions that we have here today, guys, is I know Keith started to mention some of these keywords, some lingo, if you will, when he was speaking on his inspection slides, is we hear the words AI, or artificial intelligence, and ML, machine learning. So can you explain that just a little bit more?
Yeah, sure. Without getting too nerdy and keeping it at a high level, AI, artificial intelligence, is the buzzword, is basically the process of developing systems that mimic human functions. So that you'll see the difference when we get to ML, machine learning, in a minute. So that's the intelligence process based to try and mimic humans as closely as possible, just like autonomous vehicles. So they mimic the driving, or if you have chatbots, when you're talking to somebody on your bottom right-hand screen of your computer, the idea of AI, which was the original concept, was to try and make it that if it was behind a wall, you didn't know whether it was a human or a machine giving you that result. So that's basically AI. And behind the wall, it's complicated, but it generates a very simplistic operation for the end user. Machine learning, which is like a subset of AI, provides the systems, the computer systems, etc., the ability to dynamically learn to assist the artificial intelligence. So you do that without explicitly programming it. So machine learning, let me give you there's like two ways to do it. There's supervised mode and unsupervised mode. I'll keep it real simple. Supervised mode uses tasks or class that you identify and predetermined labels that make judgments. Unsupervised learning mode works by the system analyzing uncategorized data or unlabeled data and finding patterns within the presentation to it. So for example, if you add 200 cans mixed of Coke and Pepsi, and you set a camera in front of it, in supervised mode, you could say, right, here's 5 images of a Pepsi can, here's 5 images of a Coca-Cola can, and then they would be supervised in their discretion going forward on their judgments. Or you could just take all the cans, put it in front of the one camera, run them past the camera, and it will judge, it will find deep neural patterns that will say, this one's always different to this one, and separate them. So that's the supervised and unsupervised type mode of machine learning, which then assists in deploying artificial intelligence, if that makes sense. So trying not to keep it too nerdy.
Great, thanks for that answer, Keith. All right, so as our series is, our goal is to provide the resources to, like Keith just mentioned, everyone's learning, to keep learning. And with Norwalt being the experts in the next evolution of automation, Mike spoke on the different benefits, making sure we identify the proper automation to use for the right industry, markets, products, and setups. So, and then as well as the cost that's involved, having the correct budget to be most beneficial in the areas that this technology can help us. So one more level of that being a benefit to us, Mike, maybe can you describe, do you have any information to answer, what is the life expectancy of a machine?
So well, these days it's amazing. Our machines last quite a long time. I have many a Plastek that are over 20 years old, running at 300 a minute, 250, 300 a minute. And it depends who builds them. If you're using continuous motion, they're going to last 20, 30 years, outlive the product. So it really depends. It's a lot's on the maintenance. If you go by our routine maintenance, there really isn't a life I could put on them now. We just have to do a refurb every so often for the electronics, which is these days, a big thing. Part of our business now is end of life support. on the machines, because a lot of the electronics now are becoming obsolete. So that's the more of the critical steps. The simple stuff of greasing, all that if you do that right, they'll keep running. It's the electronics now that we're starting to contact customers for upgrades on machines so they're not caught with their pants down, I'll say, with an electronic part that they have to buy on eBay.
Great. So yeah, that's definitely a great point. You know, you get what you put into it with the maintenance and always keeping up on things. We know that a legacy is a big part of what we all do, and if you take care of that, then it can last a lifetime. So speaking of the speeds and keeping up, we have two questions that kind of relate to the output production. So I'm going to start with something I thought was really interesting of you commenting on the first time that I had heard of it, again, being new to the scene. But everyone is going to be curious of the direct object printing. So the question asks, is that accomplished with a single lasing unit or multiple lasing units?
So how we have the machine we're building right now, we've done, we did initial bench test. Now we're doing it with all the motions with what we have is for one color, you have inkjet heads. We've made it so we could do 10 to 12 colors on the front of a package and 2 on the back. So it's not, I'm going to say cheap, because you got multiple colors and all that, but the flexibility is tremendous. So a lot depends on how many colors you're going to use for mixing and all that. We're just sizing the machine so we can go up to that level of colors on the front. What you have to do is you have to corona or plasma treat the package first, which in the old days we did it with flame, but that gets it so it'll hold on the surface. And then the key is taking the package, you have to have it to where it is within 1 millimeter of the inkjet head. And the key is doing it at high speed. And what we came up with was a way to do it on a continuous motion, circular, like a Crohn's labeler, I'm going to say, that everyone's familiar with, or a beverage type machine, and bringing the product in and out and rotating to keep it at a common distance to the inkjet head. So it depends on colors. If it's one color, you're going to need one head on the front, another one on the back. If it's multiple colors, you're going to need more.
Great. All right, thank you for that answer. As you said, it's in testing and prototyping. I'm sure we'll all be looking forward to some updates on that technology. So again, another question on speed. Can you update us on, for deodorant sticks, what is the highest speed assembly machines that you're currently manufacturing?
Well, I can't give out what people are doing from competitive standpoint, but it's common knowledge that assembly machines, we're doing well over 400 a minute on deodorant sticks today. That's not an issue for us. And we could go higher speeds. We're probably in the next few years, I'm sure we'll be building one in 500 plus a minute. It's just a question of volumes and all that. And it's almost, I don't know if it's going to keep going on those speeds, or now we're going to go to more flexible systems for quicker changeover and size change. So it's kind of two camps on this now, where things are going.
Give and take. All right, well, thank you. That answers our live questions. I have one more question that I'll let you guys lead into any closing statements that you have. So if we just want to recap, if somebody doesn't have a partner with an automation house already or access to one, how would you suggest somebody getting in touch with Norwalt to do an evaluation of potential labor savings, and how do you support internationally, international needs? And then I'll let you guys close out.
All right. Well, for contacting us, you can email either Keith or myself. We'll be happy to schedule something with you to talk about your business and see if we're the right fit for your facility to come out, take a look at it. and we'll do that typically around here. In Asia, we would send Albert or Tal, a couple of our engineers, out to help out in those areas. And so one thing, if you have some local automation houses, they're always a great step if it's small projects. And you can call people like Fda or ABB on the robots, and they'll give you your local automation house that does some customization if it's smaller projects. But we're happy to talk either way. All right, I think that's about it. Nicole, I'm going to turn it over to Keith to do a closing statement.
Yeah, thanks. It's been a pleasure. I know hopefully it wasn't too nerdy. We try to keep it at a high level and try to keep everybody awake, you know. But yeah, thanks for spending some time with us. Takeaways I'd like you to have from Norwalt's position on this short overview is to understand that the quality and knowledge that our team here at Norwalt has in order to support your customers and your end users and things like that with all of our automation needs. We really are a bunch of engineers. No, we're not a sales organization, we're an engineering organization. And we continuously monitor, test, develop, determine suitability of all new technologies that we can, so we can pass that on to you to make sure you're up to the latest and greatest, and we'll do all that work for you. We'll just think of us as a partner in automation, like the title says, hopefully, so that we'll take a lot of that tough work out of the research side for you as well. We actually set up research and development areas in our company for some of our partners, especially in the pharma world, but we'll do it in any world. And they'll come in and work with us and do testing and, look for a solution together. So when you're looking at an automation process or you're not sure or anything, think of us, hopefully. Our contact information's there. And hopefully this gave you a little insight of our capabilities. We do from the smallest to very, very large systems. And, you've got the CEO of the company coming out with me typically, that it really is a flat company as far as organization. It's great. Everybody works together as a team, and we'd love to see you all. All right. Thanks, Nicole.
Thanks, Nicole.
All right, well, thank you. Certainly my pleasure again working with Norwalt, the next evolution of automation. And thank you for helping Plastek always enhance our brand and being our partner. So again, to our audience, thank you for joining us. You have our contact information here. If you feel that you can share this presentation with somebody in your organization or a student or a classmate, a family member, this will be uploaded to the Plastek Group's website or the GoToWebinar GoToStage channel that you can find on our website as well, and in the follow-up email that you will again get for thanking you for being here. There will be a brief survey at the end of the webinar as you exit the screen. We thank you for your time and hope that you can answer some questions for us. Until next time, have a great day.